Welcome everybody to today's Getting Started with Kubernetes and Rancher 2.0 training. We have a lot of people joining the line, so I'm really excited to get started and plunge right in to material. We have about 90 minutes together and there's a lot that we want to cover. Just so everybody knows, this session is being recorded. You will get a follow-up email with the recording of the session, these slides that we're going to go through, and the Q&A. And again, this is intended to be a technical introduction of Kubernetes using Rancher. So we will go over Kubernetes, basic fundamental Kubernetes concepts, to make sure you understand them, and then also demonstrate how Rancher utilizes Kubernetes and what you can do. So we do have slides to get through in the first portion of this training, but this is mainly going to be demoing. It's intended to be hands-on and interactive. So if you have questions, please, put them in the chat. We try to get to as many as we can. We also often have a lot. We have 90 minutes scheduled, as I said, and so if we can't get to some of the questions, then we will try to follow up after the training. But if you have things you are wondering about now, please go ahead and put them in the chat, and we'll, space them out as we go and based on the relevant topic. As a way of introduction, my name is Matthew Shear. I'm the community advocate at Rancher. You can reach me on Twitter, or on the user Slack. You can also email me at matthew@rancher.com. Happy to be of service. And our trainer on the line is Rajashree. Hey, Rajashree, glad you're here. Really glad to have you.
Hey, yeah, thanks, Michael. Thanks for having me.
Yeah, absolutely. Cool. So that's us. And again, just for some more context, we hope that you come in here with a basic understanding of Docker concepts. If you don't, it's okay. I think you'll still get a lot out of the training. We won't talk, I'm not sure if we'll talk that much about containerization, but Registry could cover it if people have a lot of questions about it. And people do get a lot of information from these trainings about Docker. And if you have more questions that's outside of the scope of this training, we might direct you to some other resources, such as our docs or our user Slack and things like that. So if you want to follow along with your own instance of Rancher and get started, it takes just a couple minutes. You can go to the deploy button at the top right corner of rancher.com, and it'll bring you to the quick start guide, and you should be able to get up and running very soon. Kubernetes and Rancher are both free and open source. So further resources, the Slack channel is open to everyone, and we have a big community of people who utilize our user Slack. Again, it's free to get started. There's already a lot of conversation there this morning. And our forums as well have a huge repository of questions and answers. So now that we've got all of that out of the way, we can start to get into the material. So at this point, I'm gonna pass the presentation over to Registry, and she will get us going. Are you ready for the Helm?
Hey, Matt. Yeah, I'm ready to start sharing.
Okay, cool.
Okay,
Yep,
so can you see my screen?
I can. Yeah, you're good to go.
Okay, awesome. So once again, hi everyone. Welcome to the Rancher 2.0 and Kubernetes training. So like Matthew said, at the beginning, I'll be going through some slides in which I will go over some of the core Kubernetes concepts, some Kubernetes objects. And then there will be a demo for Rancher 2.0 where we will cover different Rancher 2.0 concepts and also how we make using Kubernetes much easier for you. So I'm a software engineer and I joined Rancher Labs, I think around 2 years back, or maybe a little more than that. So when I first joined Rancher, we like that time we were working on the Rancher 1.x versions, like Rancher 1.4, 5, 6, and so on. And that was the first time I got introduced to the concept of container orchestration. Like Matthew said earlier, we hope that you're familiar with Docker containers. but I just want to quickly talk about what is container orchestration. So just having a containerized application is not enough. Like you need to make sure that your containerized apps are running continuously, they are available, and your containers can get scheduled on different nodes. So you need something to make sure that the networking between those containers is working correctly. There are proper health checks to make sure that if one of your container fails, then some other container is brought up in its place. And things like storage and again health check, load balancing, all these things need to be taken care of, and a container orchestrator is something that will do that for you. So even in Rancher 1.x, we supported Kubernetes as one of the container orchestrators. But along with that, we had support for a couple more container orchestrators, such as Docker Swarm, Mesos, and we had our own orchestrator called Cattle. But when we were working on Rancher 2.0, we decided to move completely towards Kubernetes as the main container orchestrator. And Rancher 2.0 basically provides management for all of your Kubernetes clusters and a lot of great features on top of that. So the reason we made this shift to Kubernetes is because of the tremendous momentum it has gained. Even back then, we could see that Kubernetes was growing at a really fast pace. But in the last 2, 3 years, the growth that Kubernetes has achieved is just tremendous. It's incredible. So the reason being, Kubernetes is really well engineered. It originated as as a project from Google, and it's well engineered. That makes it very scalable, and it has a robust design. And these are some of the qualities that really people and companies are looking for to deploy their applications. So many software companies have already moved towards and started using K8s extensively, or are, of course, thinking of moving towards K8s. And big companies such as GitHub have publicized their use of K8s. So because of all this traction that Kubernetes gained, even major cloud providers such as Amazon Web Services and Azure have started providing Kubernetes as a service. They have hosted Kubernetes service provided. So yeah, so that's pretty great that an open source project is gaining so much popularity and even companies want to contribute to it. So as you can see from this pie chart, the major chunk of contributions, of course, come from independent users, maybe open source users, followed by, of course, Google. But you can see these list of companies such as IBM, Microsoft, and HP who are also actively contributing features to Kubernetes. And I think that is pretty great, like so many companies and so many users coming together to grow this product further. So yeah, Kubernetes is great and you want to start using it. But there will be some challenges that you will come across. For example, you might be using different infrastructure providers. So how do you make sure that your Kubernetes deployment is consistent across all these infrastructures? Is there a way to do that? Then you want to make sure that your Kubernetes clusters are secure. And that's when you will think about managing access control across your multiple clusters. You will also need to have a centralized, I mean, you would prefer to have a centralized authentication system so that the authentication for all your different clusters is managed together. Is there a way to efficiently utilize your resources by partitioning your clusters further? Then, like, how do you manage multi-tenancy? How to make sure that your cluster is highly available? And of course, again, there are different Kubernetes concepts such as pod security policies. Are they enforced across the clusters and namespaces as desired? And last but not the least, you want your application to be running all the time. So you want to have a great monitoring. You need to be able to detect any issues as and how they come and also troubleshoot them. So these are some of the challenges that you will face while starting with Kubernetes deployments. And also, like I said, Kubernetes is a very fast growing open source project. These are some of the stats that we got from the Kubernetes release cycle. And like this is like a really high number of commits. And it's one of the top 5 GitHub projects. So because of the rate at which it grows, it really doesn't have a concept of long-term support releases or versions. So Kubernetes makes new minor release every 3 months. Now, between these releases, there is definitely scope for some breaking changes. Like some of the resources you were using could be in like a different API version group now, or some might not even be supported. So, like you see all these operational challenges and how keeping up with the rate at which Kubernetes is growing and changing, all these things can be a little overwhelming, and you don't want to get stuck in like solving the same problems again or figuring out what suddenly changed. So Rancher is here for you to help you with all those things. Because Kubernetes has a steep learning curve, Rancher will make this process much easier for you. And yeah, like even if you are familiar with Docker concepts, that does not necessarily mean that you're familiar with how Kubernetes like manages Dockerized applications as well. So that's one more thing that Rancher will help you with. So like I said, these are some of the awesome things that Rancher provides. Like Rancher gives you an easy to use interface for K8s configuration and deployment. And you could have multiple like infrastructure providers being used, and Rancher will make sure that your clusters across those infrastructures are managed properly. Rancher provides automated deployment of the latest K8s release. Then we support your workloads, your RBAC policies, and projects. So project is a purely Rancher concept, and I'll be talking more about it during the Rancher demo. And of course, we have world-class 24 by 7 enterprise-grade support. Like people have amazing things to say about our support team. So yeah, you can check it out. So Rancher 2.0, it's a complete container management platform. And these are kind of the different layers at which it functions. As you can see, we have different like support for different infrastructure providers, cloud providers. For example, AWS, Azure, and we also support your clusters that you have deployed on like hosted Kubernetes providers such as Amazon EKS or GKE or Azure's AKS and so on. Then on top of that, you have the unified Kubernetes management, which takes care of like provisioning your workloads or upgrades to your workloads. It takes care of RBAC and pod security policies and so on. Oh, I'm sorry. I don't know if you were seeing this webinar screen all the time, but I'm just trying to minimize it. Yeah. So on top of this, you have the application management layer, which gives you that awesome user interface that I spoke about. We have the catalog. Uh, Catalog lets you launch any of your applications like with a single click in any of your clusters. CI/CD, monitoring, logging, and so on. So this is like a high-level architecture diagram for Rancher 2.0. In the topmost box, in the right in the middle, you can see this blue box that says Rancher API server. And Rancher API server is what takes care of all of your like your clusters. It's like it starts your controllers and so on. So yeah, Rancher is also using etcd. So like yeah, so like I said earlier, you can have different Kubernetes clusters from different cloud providers or different infrastructure providers managed together by Rancher. So that's what we have here. We have RKE, which is Rancher Kubernetes Engine. It's a way to provision Kubernetes on your nodes. And we have its nodes running. And we also have some nodes from your GK cluster running, both of them being managed together by Rancher's cluster controller. So it's pretty awesome. Now I'm going to go over some of the core Kubernetes concepts, like I said. Now, these Kubernetes objects are purely Kubernetes concepts. I mean, no matter how you're deploying your cluster, how you're managing it, even if you're not using Rancher, these objects still stay the same. So I'm going to cover pods, deployments, services, config maps, and ingresses. So first object is pods. A pod is the smallest deployable unit in Kubernetes, and it can consist of one or more co-located and co-scheduled containers. Like they always get scheduled together. Each pod is given a unique IP address. Now, since these pods are co-located, they share the same network namespace, same volume. And because of this, the containers in a pod can speak to each other directly via localhost. Now, coming from the world of Docker, where container is the smallest unit, this concept of pod can tend to get a little confusing. Like, when would you need multiple containers in a pod? But you don't need to worry about it too much right now because, according to Kubernetes documentation, the one container per pod model is the most common use case for using pods. So you can just try to think of pods as containers for the remainder of the training. So this is an example of a pod running more than one container. We have an Nginx and Redis container, and since they are co-located, they can directly communicate to each other via localhost. Now let's talk about replication control or replica sets. So replication controller, yeah, it ensures that like a desired specified number of pod replicas are running at any given time. uh, Basically what any controller in Kubernetes does is it asks you for a spec, your desired state of application, and then it tries to make sure that the status or the state in which your application is right now matches the spec. So that is replication controller. Then there is replica set, which is the next generation replication controller. But currently, the only difference between them is the selector based support. Like replica set, I think it supports some new selector mechanism, whereas replication controller has selectors based on equality. So this is what a replica set is. Like say, let's take an example where I have a deploy, like I want to run 12 of my application pods at any given time. That is my spec or desired state. Now, I have scheduled them, and these 12 pods are distributed across these three nodes. Now, let's say something happens and one of the nodes goes down. The replica set is like it's supposed to make sure that the four pods that are lost on this node are somehow scheduled on the remaining nodes, and that's what it does. So it makes sure that at any time, my actual number of pods is the same as my desired number of pods. But the replication controllers are like deprecated, and you will more commonly and more frequently see people using deployments. Um, what is a deployment? Deployment is a level of abstraction above replica sets. So deployments are used to manage, like create and update your replica sets. And not just that, deployment also provides you a lot of cool, useful features, such as it lets you easily scale your apps and it lets you perform rolling upgrades on your application. So by default, the Kubernetes deployment, it supports actually not like the Kubernetes deployment. When you're setting it up, you can decide whether you want to provide rolling updates or you want to have recreate strategy for your application update. And by default, deployments has a rolling update strategy selected. So let's say you have these pods running for your app and they are running the version V1 of your application. Now it's time to update to V2. So you bring up new pods to run the version V2, and you also start sending traffic to it. If you see everything is working fine, you can eventually move on to have your app only running the version V2 of your app. Like you can have pods that are only running the version V2, and you can get rid of all of the pods that were running the version V1. But again, there are commands such as kubectl, I think kubectl rollout. I'm not remembering it particularly, but with which you can just, kubectl rollback, with which you can go back to your previous version if something were to go wrong. So yeah, the next concept we look at is a service. So we have seen how a pod gets a unique IP address. And basically, that IP address makes that pod accessible by all the other pods and deployments within the service, within your cluster. Now, let's say for some reason your pod goes down. We saw that a deployment will like manage the replica sets, which will bring up another pod in its place. But now this new pod has a different IP address. So any other pods that were referring this pod, like how do they keep track of this? How do they find out this new IP address? Or how do they really keep track of the other pods that they want to communicate with? And that's where the concept of service comes in hand. It's very helpful. So a service defines a DNS entry that can be used to refer to a group of pods. It gives you a consistent endpoint for your pods. Now, there are different types of services. One is the cluster IP, which exposes the IP of the service within the cluster. Then there is a service of type node port, which exposes your app via an IP address and port on each node. Then there are load balancers, like they're layer 4, and they work with a cloud provider to create public IP addresses for your app. So this is how it works. Traffic is hitting your service IP address, and then based on selectors, like it knows where to which ports to route the traffic to. The next Kubernetes object that we'll go through is a config map. Now, when you're running some application, you might need certain configuration files or values. For example, if you're running an Nginx app, then you might have a configuration file such as default.conf, and yeah, you might want to keep changing the contents of that configuration file as well. Even if you're using just some like environment variables, you might want to keep on updating those too. So it's a really, like, it's not recommended to have all those configurations baked into your main container image, because then every time your configuration changes, you will have to recreate your container image as well. And then you will have to run like pods with this new container image. So Kubernetes gives you a great way of avoiding that by using this config map. So in config map, you can store all of your arbitrary configuration values and files. And then this data in a config map is exposed to pods by, you can expose it by two methods. First is via environment variables, and second is via volume mounts. So yeah, this is an example. Like we are creating 3 different config maps for 3 different use cases. Let's say I have one cluster in which I want to just have all, like I just want to give access to the dev team. One is for QA and one is for production. So I'll create different config maps for all these 3 use cases. And that way I can provide, like, let's say I just want to provide different environment variables. So this is a really clean way of doing that. And the last thing that we'll go over is an ingress. Now, like Ingress deal with like layer 7 load balancing. They decide how traffic outside the cluster is routed to inside of the cluster. Ingress exposes Kubernetes as like the Kubernetes services to the world. Now, within Ingress, you can route traffic to internal services based on a host and path combination. And Ingress is usually implemented, yeah, by load balancer, like I said. And by default, Rancher has Nginx, but you can use other things such as HA proxy, AWS, and so on. So this is an example where your Ingress controller, in this case, Nginx Ingress controller, is getting some requests from the client. And then based on the host and path combination, it knows which service, like which service inside your cluster to forward those requests to. And then that service can forward that request to the pods that it is supposed to. Okay, yeah, so these were the core Kubernetes concepts. And I think it's a good time to just pause and take some of the questions that you might have. So Matthew, are there any questions?
There aren't any right now, no. So keep going. You're good.
Oh, okay, yeah. Please feel free to ask questions. I'll answer as many as I can, and if not, I'll be using the Rancher or even Kubernetes documentation. And yeah, you can also post them in the Rancher user Slack channel. So I'll just go ahead. Now let's begin with the Rancher 2.0 concepts. This is what all we'll be covering today. We'll see how to set up your Rancher server, how to install it. Then we'll see how you can add multiple clusters to your Rancher setup and how Rancher manages them. How we provide authentication and security, like centralized authentication for your clusters. We'll go over storage and the Rancher concept that I earlier mentioned, that is projects. We'll go over how namespaces can be managed by Rancher, and catalogs and Rancher CLI, API, etc. So yeah, demo time. Okay, so sorry about that. Yeah, so for installing Rancher, I'm just going to go to docs. Like to do that, you can just go to this rancher.com/docs. Now you come here, you can select rancher2.x and read the docs. On this left, on the navigation pane on the left-hand side, you can see installation. Once you click that, you can, let's first check out what are the node requirements. Like these are some of the requirements that your node on which you will install Rancher server needs to meet. So first is the operating systems. These are the operating systems that Rancher supports, and also we support the subsequent releases. Like these are the ones on which we have tested and seen that Rancher server works as expected. Then these are some of the hardware requirements. Depending on how many clusters you want, we suggest to you some of these requirements. Then in software requirements, of course, you need to have Docker supported. Docker running to install your Rancher. These are some of the supported Docker versions. Now, when I say supported, that's something that we have used for our testing, and we know Rancher server works fine with those Docker versions, but you might be running some unsupported Docker version as well. And as long as your Rancher server is running fine, you don't need to worry about it. And last but not the least, the networking requirements. So yeah, the IP address of your node needs to be accessible all the times, and these are some of the port requirements. Now, this is important. You need to quickly take a look at this. These are the different ways in which Rancher will be managing your clusters. For example, in some cases, some of the clusters, Rancher will launch Kubernetes for you. Or in like if you're using some hosted Kubernetes providers such as GKE, EKS, AKS, Rancher won't be provisioning K8s on it because those cloud providers have already done it. Rancher will just be managing those clusters. And you could also have some cluster, Kubernetes cluster already running. No matter how you have managed to provision Kubernetes on it, you can just import it within Rancher and run it. Now, for all these types of clusters, you need to have port 443 open. This is because we open WebSockets for communicating between clusters. Now, in the case where you, let's say this first type of cluster where the nodes in your cluster are hosted by an IaaS, infrastructure as a service, and let's take the example of DigitalOcean. Like it does not have its own hosted Kubernetes service. So in that case, you also need to open your SSH port 22. This is because we'll SSH into that node and then we'll install Docker on it and then we'll provision Kubernetes. So these are the ports that you need to keep open for that case. And then if you're using a hosted Kubernetes provider cluster, you also need to open port 6443 so that Rancher can access the API server, and that way we can manage your cluster for you. So these are the node requirements. And okay, the server tags section just shows you which tags are there and which ones to use. You can go through it if you want. I'm just going to use the latest tag because I'm just showing in this demo, I just showing you the development release, but the stable release is recommended for production. So let's go to installation. You have many other options, just high availability install and air gap install, but for the purpose of this demo, I'm just going to stick to a simple single node install. So first of all, you need to provision a Linux host, and for that, like these are the requirements that we just went to. So I've already provisioned a Linux host. Yeah, okay. Yeah, I've provisioned a Linux host based on the requirements. And now these are the commands that you can use to install Rancher server on your host. These are different options based on the type of self-signed certificate that you're using. Let's say you're just using Rancher installation for a development or a testing environment. You can use the self-signed certificate that Rancher generates for you by default. But if you were to use your own self-signed cert, then you can use this option. You can go through it. There's also an option to use your certificate, which is signed by a certificate authority, or the last option is the Let's Encrypt cert. But for the purpose of this demo, I'll just be using this default self-signed certificate option. So I just have to copy paste this command. I already have Docker installed on my node, the supported version, and I'm going to run this command. So as you can see, it is pulling this Docker image, Rancher latest. It is available on Rancher's Docker Hub, so you can take a look at it. And it will take some time to actually like pull the Docker image and start the Docker container running the Rancher server for you. So yeah, the Rancher server is up, but it will just take some time for it to get fully started. You can just follow the logs if you want. So as you can see, like I went over some of the resources that Kubernetes has, such as pods and deployments. But Rancher, like there are various ways in which you can extend Kubernetes, and one of them is via custom resource definition. And Rancher needs to create a lot of CRDs, custom resource definitions, for managing your Kubernetes clusters, and that's what it is doing right now. So okay, let's see if it is up and running. Okay, so when you first come here, because you have self-signed cert, you just need to allow it, like proceed to it. So the first thing you will do is you have to set some password. Uh, like by default, we have some we have local auth enabled, but you need to update your password. And the second most important thing is the Rancher server URL. When you're saving this URL, just make sure that this URL is accessible all the time. Okay, that's it. I'm saving it. Yeah, so now this is your Rancher server setup. And as you can see, I have no clusters right now. So the first page itself asked me to add a cluster. But before that, let's take a look at the different tabs that we have here. Like these are different node drivers that we support. Some of them are active, but if some aren't active, you can activate them by clicking on it and selecting it and clicking activate. Then there's a catalog app, which I mentioned earlier, but I'll discuss in detail later on. You can create some local users here. These are the different settings in your Rancher server. And sure, like we have local auth enabled, but you want all of the users in your company to be able to access that Rancher server installation. So one of the great ways to do that is by integrating Rancher with some existing authentication provider. So for that, let's go to security authentication. And over here, you can see we provide support for these great authentication providers. You can select Active Directory. And it's an awesome feature because if you have an AD server running with all your users and groups in it, you can just provide all these details and integrate, like create an integration between your Rancher server and your AD server. So by that way, all the users and groups in your AD server will be able to access your Rancher server. Then you can also use Azure AD. Some of the other LDAP providers that we support are OpenLDAP and FreeIPA. And recently, we have also provided support for SAML-based authentication providers, two of them being Ping Identity and Microsoft ADFS. So detailed information of how to set up these authentication providers, like how to integrate with them, is provided in our Rancher docs. You can, I think it's under administration authentication. Yeah, you can check out all these authentication providers and how to set them up in Rancher from here. So, and this is the GitHub authentication provider. I think like this is very easy because you just have to click here and it takes you to a developer apps. You create a new app and we have already given you what all fields you need to use to turn on authentication. Now, like I said, I don't have any clusters or anything in this setup, and it usually takes some time for, say, a GKE cluster or a DigitalOcean node to come up. And because I didn't want to spend more time doing that in the training, I have already created a separate Rancher server. And yeah, this is my Rancher server. I just created it yesterday, and I used the exact same steps to install Rancher server on this this virtual machine. As you can see, I've already enabled GitHub Auth, and that takes all of my information from GitHub and logs me into the Rancher server. Now, I can provide access to any users or groups, organizations that I want by using the site access panel, first of all. In the site access, I have three options available. Like if I select this, then just anyone who's trying to log into Rancher will be able to. But I don't want to do that. I have already saved the second method, which allows members of clusters or projects and also authorized users. Now, these members of clusters and projects, it's something that we'll take a look at very soon. But this authorized users and organizations is the list of users that you will see over here. Now, from this drop down, you will see that, like, if you are logged into Rancher, in this drop down, you'll see all the groups and organizations that you are a part of. And you can just select anyone you want. So let's say I want all of the users in the Rancher org to be able to access this cluster. I can select that and I can save it. And this third access mode basically just restricts access to only the list of users in this authorized users and organizations list. And even people from even members of clusters and projects won't be able to access. So, okay. Now let's take a look at how exactly we'll create clusters. Now you can have 4 different types of clusters managed by Rancher. The first option by which you can have your, the first type of cluster you can have managed by Rancher is that of a hosted Kubernetes provider. Now we have 3 hosted Kubernetes providers, that is Google's GKE or EKS, AKS, and so on. So let's take a look at GKE. So over here, you just need to provide some cluster name. Let's check out this member role section. So while setting up authentication, I told you that I was talking about those 3 different access modes. One of them allowed users that were members of certain clusters and projects to be able to access Rancher. So this is how you can add a member to a cluster that you're creating. Right now, only I am a member of this cluster, and since I'm creating it, I get the role of a cluster owner. But I can add more members to it if I want. Like, let's say I want to add Matthew. There are there are many users, and I'm not sure which one he is, but I'm not actually going to add him to the cluster. I just wanted to show you how you can. And once you type in the name of the user or the group that you want to add, you can select from among these 4 roles which role you want to assign. You can make that user an owner of your cluster, giving the same set of access that you will have. Or you can add this user as a member, read only, or you can select the custom role. So if you select the custom role, you get to choose the permissions that this user can have from this list. Whether you want the user to just be able to create projects and view projects, you can just decide any combination of permissions you want. Right now, I'm not adding anyone, so let's just go ahead with the creation. And this is where you'll upload your the service account JSON file. And let's see if I can train. Okay, and once that is done, once I'm authenticated, I can go to nodes and I can configure the nodes. So over here, these are the options that you will also see in the GK UI. So you can select which zone you want, which machine type you want, and so on. Right now, I'm not creating the cluster because it takes some time for the cluster to come up, but just following the same steps, I've already created this GKE cluster. So let's check out the second way of creating clusters, which is from nodes in an infrastructure provider. Let's say, for instance, DigitalOcean. You have some nodes on DigitalOcean, like you want to use DigitalOcean droplets and you want to provision Kubernetes on it. And the way to do that is by having Rancher install K8s on it. So in this case, like in this option where your nodes are in an infrastructure provider, Rancher will be SSHing into your node, and Rancher, like I said earlier, will install Docker and K8s for you. You need to give some name to it. This member role section is again the same, and it is common to all types of clusters. It grants membership to any users that you want. Now, these are some of the cluster options which are also available in different clusters, such as you can select what type of Kubernetes version you want to use. You can select the network provider. You can select from Flannel, Calico, or Canal, and by default we have selected Canal because it kind of offers the best. And with Canal you have the option of enabling or disabling project network isolation. Then you can select whether you want Nginx ingress enabled or disabled, monitoring, pod security policies. Pod security policies, again, a Kubernetes concept, and I'll be talking about it later on. Then comes the question of Docker version that you're using. Whether you want all the nodes in this cluster to require the supported Docker version, or you're okay with just using unsupported version as well. It's up to you, as long as Rancher is running fine. And okay, so node pools. So this is where you will actually like configure the node that you want to run. So this is how you'll do it. Like, okay, I have already created a node template, but you can create one by going here. You have to provide your DigitalOcean API access token. So for that, can you see my screen? I just enlarged the font a little.
Yep, I can see it. You're good.
Okay, so yeah. Okay, let me just get this token and okay, so once DigitalOcean authenticates me via my access token, I get this page. Now, if you're starting a droplet using the DigitalOcean UI, these are some of the options that you'll see there. Like you will see the region in which you want your droplet to be running in, or you can select some droplet size, which image you want to use, and so on. And it's pretty great that Rancher lets you provide these options from here itself. And by default, we had selected some size, and it's recommended that you try to make sure that your droplet size is big enough. So yeah, and again, right now, like you can just create a Rancher template if you want, but I have already created one, this template. So once you select whichever template you want, you need to select which roles you want that that node to have, such as HCD, control plane, work or worker, and so on. And again, that can also take some time. So I've already created a DigitalOcean cluster prior to this demo, and I've used the exact same steps for doing that as well. So let's check out the third way of having clusters managed by Rancher, and that is from your existing nodes. So for that, you will again provide some cluster name, let's say, okay, directory custom. And then in member roles, again, you can choose who has access to this. These are some of the cluster options that you have, which are again the same. Oh, hang on, sorry, I didn't say, yeah, I was good. Okay. Sorry, I had selected the DigitalOcean option, whereas I wanted to show you the custom option. And I misspelled my own name. Okay, so these are the member roles. These are the cluster options. As you can see, we have one more cluster option here, which is the cloud provider. So since you are using your existing node, that node could be on Amazon or Azure, and you can just select that for now as well. So let's click on next. Okay, now this page lets you decide what all roles your node will have. And since for this demo, I just want to quickly show you how you can set up a custom cluster, I am going to select only one node with all three roles. And Rancher gives you this command that you're supposed to run on your existing node. So, okay, this is the node I had created for, yeah, this is the node that I had created earlier, sorry. Okay, so as you can see, Docker is installed, but no Docker containers are currently running. And I'm going to just copy paste this command here. And it's pulling the Rancher agent image. Now, this is something that we need to actually do all the installations for you. So let's see, in a few minutes, it should be running. So yeah, the container is up and running. And when you go back to the UI, you can see here, it says that one new node has registered. So that way, Rancher keeps on keeping track of what all nodes you are adding to this custom cluster. Let's click on done and go back to the clusters page. This page gives you a list of all the clusters that you are currently managing. And as you can see, my custom cluster is also being provisioned. It will take some time to come up, but we can just check out the next option, which is importing an existing Kubernetes cluster. Now, this could be any cluster. You can create it anyhow you want. And import, let's see. Like over here, you can just get to choose what all member roles you want because you don't get all those other options because you have already provisioned your K8s cluster somewhere. So I'm going to create it. And these are some of the options. Like for example, if your K8s cluster already has a cluster admin role, you will be using this command. If you're running kubectl commands on some existing K8s cluster, but like you're not using the self-signed certificate, then you can use the second command. But if you're using the self-signed cert, then you'll use this third command. Now let's see. So yeah, I'm using an RKE provision cluster, and I'm just going to copy this command here. So this is all that command has done. Like in your existing K8s cluster, we have created these few Kubernetes objects such as namespace cattle system and service account, cluster role binding, deployment, and so on. These are some of the things that we need to deploy in your cluster so that Rancher has access to it and Rancher can keep on managing the cluster. Let's go back to the UI. As you can see, I think this imported cluster is also now getting created, and the custom cluster is the imported one. Like it's went to active immediately because the cluster was already provisioned and I just imported it. So, okay, we just wait for this also to come up. Yeah. Okay. Now, are there any questions that like I can answer right now?
Yeah, there's a few. Let's see. So Vladimir asked, in cluster config, there's the option Docker root directory. Does this option apply to the whole cluster or to only one node? Do you know?
Docker root directory. I think it should, yeah, I'm not sure, but I think it should apply to like all the nodes in that cluster.
Cool. Okay, awesome. Anything else you want to add there, or should I go to the next question?
Oh, yeah, you can go to the next question.
Okay, great. So TJ asks, when do we use control plane on pods?
Control plane on pods. So, like the control plane is what will take care of your API server and schedulers and so on. And your pods and other workloads are like, I'm not sure I exactly understand the question, but yeah, the control plane is responsible for your API server and so on.
Okay, cool. And TJ, if you want to elaborate or clarify your question, that'd be helpful too. Okay, the next one is from Derek, who asks, can you explain what cluster partitioning is and at what point you would consider creating partitions?
So like the cluster partitioning, like are you talking about okay, so I'm just going to assume here that you are mentioning about how you can like partition your workloads. When I say partition your workloads, meaning like how you can further segregate your cluster. And for that, you already have namespaces. Like if you're creating some namespace, then you can have RBAC, and by that means you can have some users access, like provide some users access to resources in a particular namespace. But on top of that, Rancher also has its own feature of projects, which like groups multiple namespaces together. And I'll be talking about it soon, but that's a great way of like partitioning your cluster so that like only some users have access to some resources, and those resources get isolated from all the other teams within that cluster.
Awesome.
Yeah, I hope that answered your question. But like again, if I'm not answering your question like you want, you can please post it, like rephrase it, or like you can post it on the Slack channel as well. Yeah.
Cool. Okay, there's a couple more. The next one is from Andrew, who's been waiting on this question. It is, besides the small footprint, are there benefits to using Rancher OS on cluster nodes?
So like I haven't actually worked on Rancher OS, so there are definitely benefits, but I don't think I'll be able to answer that question for you. I'm really sorry, but let me, I don't know, let's see if I can pull up some docs on Rancher OS. But like you can definitely refer these docs, like, oh my God. Uh, Yeah, I'm really sorry. I won't be able to answer this, but I'll try to make sure that I'll post some link on the Slack channel.
Cool. Okay, I'm going to go to the next one. This is from Marcus, who asks, does Rancher support other container engines like RKT or CRI-O?
So like other container runtimes, so basically we are using the Docker container runtime like by default, but if you wanted to customize it, then I haven't personally done it, but maybe there are like other users who have done it. I'm not sure about that, but like Docker is the one container runtime that we are using by default.
Cool. Okay, there's several more questions, Rajashri. Do you want to take those questions, or do you want to keep going your demo?
I guess if like yeah, I don't want to I mean I would definitely want to answer the questions, but then I don't want to spend more time on that. Like I want to cover the other parts of Rancher 2.0 as well. So I guess I'll go ahead with the training for now.
Okay, cool.
Sorry about that. Yeah. So let's say, okay, these are the clusters that I've created, and we have been over the different methods, different types of clusters that you can add to Rancher. Let's take a look at this GK cluster I've created. And this page gives me a list of all the nodes that are there. So first of all, I just click on this cluster option for GK. This shows the number of nodes that I have running, and it just shows that all these things, just scheduler, controller, manager, are all running as expected. Now let me go to nodes, and let me click on one of the nodes. Now this gives me a detailed information about this node, such as what operating system, what Docker version, what all it is using. And yeah, if I click on the status, then it gives me even further detailed information about this node. You can check it out if you want to. Now let me go to the DigitalOcean cluster. So hang on just a second. Yeah, in this DigitalOcean cluster, I'll again go to the nodes page. And over here, it is showing that I have one node running. Now, if you can see over here to the right, I have this option of like this plus minus option of adding more nodes or removing some nodes. Let me just go back to the GK cluster for comparison. Over here, I don't have that option on that node, on the nodes. But in case of DigitalOcean, I do. Now, this is because the DigitalOcean cluster is something that Rancher provision, whereas a cluster from some hosted Kubernetes provider is not provisioned by Rancher. Like we are only managing it, so we can't add more nodes for you. But in case of DigitalOcean, like the clusters that Rancher has provisioned, we can do that. So let's say I just want to add one more node. Now, what this will do is it will use the node template that I had used for creating this first node, and then it will create another DigitalOcean droplet. It will provision it, and it will install Docker on it, and it will make sure that this node also becomes a part of your Kubernetes cluster now onwards. So I think this is pretty cool with like how you can just scale nodes easily. So this will take some time to come up, and let's see. Yeah, one more cool thing is if you come on this cluster tab when you're in a cluster, if you like, you get these options of like getting the kube config file for this cluster. So Rancher knows which cluster you're on, and it switches context appropriately, and then it gives you the kube config for this cluster. And you also have the option of launching kubectl in the Rancher UI itself. And that is also very amazing. I'm just going to run the kubectl get all command. Yeah, okay, it's showing me the service that is currently running. Also, one more thing, if in Kubernetes, most of you might be already familiar with it, but if you want to list all the resources running in all namespaces, you can use this all namespaces option. And that will give you a huge list of the different deployments and pods and services that Rancher has started or that are already running on your cluster. So this kubectl option is also pretty cool. You can just launch your kubectl here. You don't need to like you can just launch the kubectl shell here. You don't need to copy the kube config somewhere, and then like you can copy the kube config if you want to launch kubectl locally, but this is another cool way of doing it. So let's see. Yeah, the cluster is updating because it is still provisioning the second node that I had added. Okay. Now, yeah, these are the node drivers that I spoke about. You can, like, these are the ones that are already active, but you can activate like, them if you want further. And let me just go to one of the clusters, nodes, went through the nodes. And now let's take a look at the storage tab. So in storage, first we'll take a look at persistent volumes. Like you can see, there are no volumes right now created. And if you want to create a new volume, you can just click on add volume. You have to provide some name for it. And you can choose from this list of volume plugins that are currently available within Rancher. So you can choose your EBS disk or Azure or whichever one that you want to select. And so while doing this, please make sure that you're using the appropriate plugin for your cloud provider. Like using some cross cloud provider plugins can create problems. So make sure you're using the same plugin like on which you have, I mean, the plugin that is supported by your cloud provider, basically. So yeah, these are some of the ways which you can customize. Like you can have the different read write options, single node read write or many nodes read only, and so on. You can assign the like the volume to a storage class, and right now I don't have any created. And the second thing that you can do is, yeah, okay, so sorry, I forgot to mention that like when you create this persistent volume, you can bind it via like to a pod via a persistent volume claim. And then this disk that you select is mounted into the pod for you to use. And it's pretty awesome. You just have to provide these few things and like it will just work for you. The second thing we'll look at is the storage class. Yeah, right now I don't have any storage classes created either, and this is how you can add one. We have different provisioner options you can select from, and depending on whatever provisioner you are selecting, you get to configure the provider specific parameters. So for EBS disk, you have these options, but if you were to select Azure disk, then you have a different set of parameters which are used for Azure disk. And yeah, that's it. That's how you can easily create a storage class as well. The next thing we look at is projects and namespaces. Like finally, I've been mentioning projects for a while, but now we'll look at what it is. So you can either add a project, but like before that, I just wanted to show you some existing projects. Like let's say we have this project default. So in this, if you go to namespaces, you will see that the default namespace is running. Now, you must have seen if you start a Kubernetes cluster, you always get a default namespace. And this, like in case of Rancher, we create a default project in which we put the default namespace. So like namespaces are really great with which you can create certain resources in some namespaces. Then you can, let's say, use a cluster role binding or a role binding, and you can assign some subjects to those role bindings. And by those role bindings, you can decide which users have access to resources of which namespace. But Rancher also wanted to provide another layer on top of that, and that is a project. So projects group multiple namespaces together. And by that means, like let's say you have different teams running within the same cluster, and you want to ensure proper resource utilization between them, but you also want to give access to multiple resources to a particular team. So you can add all those team members to one of the projects, and then all those team members will be able to access all the resources within all the within all the namespaces of that project. So this is the default namespace right now, but you can just add a namespace if you want. Yeah, and that's it. It gets created very easily. Okay, let me go to the system project. Now, these are just some of the namespaces such as kube system, kube public, which already exist in your Kubernetes cluster. And this cattle system namespace is something that Rancher creates. And for your cluster to be able to managed by Rancher, you need to have this cattle system namespace in it. Like if you if you delete it, we won't be able to access the cluster. So just like you don't need to actually do anything change anything within the system project. You can just leave things as they are. And let's see. What else? Yeah. So while creating this cluster, I had shown you how you can add some members to the cluster. And even if, like, let's say you have already created a cluster and some new people are joining your organization, you can, of course, add those new people as well to the cluster. You just have to go to the members tab and click on add member. And again, it's the same way of adding members. Either from the drop down, you can select some organization or group that you're a part of, or in the search box, you can just type some name. Yeah, I'm not going to actually add anyone, but these are the permissions that you can assign to this newly added user. And yeah, you can just click on create, and that will add a cluster member. Right now, I have only one cluster member, that is me, and like all the members that you add get listed on this page, so you can quickly access them. You can view them in API, or if you delete them, then that user will no longer be able to access this cluster. So that's one way of revoking their access. And I guess, yeah, that's all that I wanted to talk about for clusters. Now let's take a look at catalogs. So catalog is like a collection of Helm charts. You can create your own repository or your own library of Helm charts, and you can just add it to Rancher via this catalogs app option. By default, we have this catalog called library enabled. Now, as it says here, it's an official repository of curated application templates that are maintained by Rancher. We also provide support for a catalog called Helm stable, which is nothing but like the apps or charts that are declared as stable by Helm. And you can choose whether you want to enable them or disable them. The library catalog is enabled by default. But let's say you wanted to add your own library of catalogs. You can do that by typing add catalog here. Let's see, I have to give some catalog URL. I guess I have one which I can use. Charts. Yeah, you need to make sure that you're providing this .get at the end, so that you can so that we know that you're adding a GitHub repository, and you can provide whichever branch you want, and then you can add it as a catalog. And yeah, and then Rancher will get all the application templates from that catalog. So where do you exactly use these application templates? Now, to actually use them, you need to go to a cluster, and within that cluster, you need to go to a project. So once you're in the project, let's check out the different things in the project first. Like, first of all, you have the workloads tab. And over here, we list all the workloads that we have created. Right now, we don't have any. But now I want to launch one of my apps, let's say. So I go to the catalog apps tab. There are no apps launched yet. Let me just click on launch. And I don't know yeah, okay, fine. I'll just launch the Prometheus app. So once I go there, actually at the top, you can see the different categories. You can sort the catalog apps by categories, or you can select which catalogs you want to list. Like you only want the library catalog templates, or you want all catalogs that you have added. Right now, I only have the library catalog. You can also search for your application template by name, which is pretty cool. Now let's select Prometheus. This gives you a description. Now, these are all the things that you provided in your library, and we pull all of that information together and combine it so that you can just launch an app with a single click. So if you wanted to make some changes, you can click Edit YAML and do that over here. I'm just going to cancel that. I'm just going to, yeah, I won't actually go over all these options because you can take a look at it yourself. The library catalog is enabled by default all the time. And let's say I'm going to click on, yeah, I click on launch. So it will take some time for the different workloads in this application template to come up to be active. Like as it's saying, it's deploying it currently. Let's go back to the workloads tab. As you saw earlier, there was nothing on this workloads tab or nothing in load balancing. But because I launched that Prometheus application, all the workloads that were defined in that chart are now coming up. And I didn't have to do anything in this case. It's just getting launched by itself. So let me go back to this. Yeah, it might take some time to come up. And oh, I also wanted to show you that even if you are not launching a catalog application, if you just wanted to launch one workload, you can do it by clicking on deploy. Then you can select whatever image you want, like either from the list of images that we have, or if you wanted to add one of your own image, you can do that. And the default workload type that we create is a deployment of one pod. Now, you don't actually launch just a single pod in a cluster because, like, what's the point of it? Like, a pod is an ephemeral entity. Like, if it goes down, you have no way of knowing that it went down. That's why you will always use a deployment. That's what we had earlier discussed. And, like, that's what we do here. We create, by default, a deployment containing one pod so that that pod, the life cycle of that pod gets managed. Let me go back to the workloads page. Let me go back to the catalog apps. It looks like it is almost up. Um, okay, so it shows that it is active. I hope something shows up quickly. Okay, in the meanwhile, I'm just going to go over to the next section, which is these different resources, such as registries. You can add some registry, like you can provide your credentials in it and add this registry, or you can configure some alerts. There are some built-in alerts, but you can add more alerts if you want. When you add an alert for some pod or some workload, you can select, like you need to specify where that alert goes to. You need to specify some notifier. Right now, there's no notifier created, so you can create one. Hang on. Sorry. Yeah, you can go to notifiers and add a notifier. You can select which notifier you want from among these options. Like it can either be a Slack notification or an email or an actual webhook URL. And yeah, that's how it will work. Okay, for some reason my application isn't coming up, but I'm just going to try one more time to see. Oh, okay. Okay, just for the sake of it, let me just launch some other application as well. Okay, I'm just going to move on to the next thing, and like I showed you, you can add members to a cluster. You can also add members to a project within a cluster. It's the same way with which you can do that. Okay, so the next thing that I want to cover is the Rancher API. For that, let's go to If you want to view the API for anything that you are running in Rancher, let it be a cluster, let it be a workload, let it be any user that you have added, you can just click on these three vertical dots, this vertical ellipses, and go to view an API. And over here, you can see the different options that are there, let's say for this node. But if you were just to go to V3 nodes, you can actually use this API to create a node from here if you didn't want to use the UI for some reason. And this will show you the request, the equivalent curl command, and you can just use this to run anything you want. So I think that is pretty cool. You don't necessarily need to use UI. If you don't want to use UI for some reason, you can always use the API. Okay, I'm just going to quickly see if my project, if my workloads are running as expected. Okay, this is live demo not working is really bad, but I think it happens all the time. So you get the idea. Like you can basically launch any application template this way and you can access it. I'm not sure if I'm missing out something right now, but definitely check it out. You can have your own Rancher server installation and launch as many apps as you can. Now, the last thing that I want to cover is the Rancher CLI. This is another cool Rancher feature, I think. For that, you just need to go to the bottom right corner of your screen. You can see the download CLI option. You can click on it. You can select based on your OS. I'm running this on a Mac, so I'm selecting Mac OS. And it has installed the Rancher CLI. So let's go to that. I'm going to go to Rancher CLI that it installed. Yeah, let's see how we can use this. So these are the different commands that you can use for Rancher CLI. Now, Rancher CLI is pretty cool. Like even if you weren't using the UI or API and you just wanted a way to manage different things in Rancher via CLI, this you can definitely use this. But to begin using this, you need to log into Rancher, and this is how you'll do it. Again, and let's see what all things you need for the login command as well. So you first need to create a token for yourself and provide it. And the way you can do it is you can go here. Sorry, you can go here, you can go to APIs and keys, and you can add your own key. And you can decide when that key will expire, when that token will expire. You can choose any of these options that you want. One more thing that you need to make sure is that when you create this token, like you are creating it for a particular user. So even if you remove that user from Rancher, you need to make sure yourself that you are also revoking that token, like you're removing that key as well. So now I've created it. And let's see, for my command, I need to use token. This is the token that I'll use. Oh, another thing, like it says here, save the info above. So this is the only time that you'll get to see the token. So you better save it somewhere, or the next time you'll need to generate another token. I've provided the token and I also need to provide the endpoint. That's what I'm going to do. So it shows me the certificate that I'm using, and do I want to continue connecting? I do want to. Yeah. Now this is another cool thing that like it shows you the different projects that you have created within cluster. Now, when you're using kubectl and let's say you want to manage different clusters, you need to, I think you need to do some context switching between the clusters. And Rancher is also letting you switch from one context, like say one project in a cluster to some other project in a different cluster and so on. So at the beginning itself, let's say I just wanted to select the first project that is showing me, that is the default project from my DigitalOcean cluster. And that's it. I guess I should have access to all the resources within that project. Let's see, like nothing is running right now, but I will be able to see like what all is running later on. Okay, now let's say I want to switch to a different context. So I'm just going to run context switch. And I am going to select the default project for my custom cluster. Let's see what all I have running there. And that's where I had deployed the Prometheus and Grafana applications. And yeah, you just get to see what all different things Rancher is running, managing for you. So yeah, um, I think I've covered all the concepts that I wanted to discuss. So if you guys have any questions, please ask. I'll try my best to answer them.
Yeah, cool. Thank you. Thanks, Rajashri, for going through all that. So cool. Let's start at the beginning. This is from TJ, who asks, um, will you allow generic SAML providers to be configured as well, since SAML is a standard?
Mhm. So, right, SAML is a protocol, and there are different implementations of SAML, such as like we will provide support for Ping Federate or Microsoft ADFS. We are also adding Keycloak, I guess. But the thing is, in the Rancher 1.6 version, we had a generic SAML provider. Like we were using the same provider to let you integrate your existing identity providers. But the reason we are not doing it anymore is because to say that we are supporting a generic SAML provider, we need to make sure that we have tested it with all the existing SAML implementations. So we decided that just one by one, we can provide support for those integrations, like as and how we test them. So we have officially tested the Ping identity and Microsoft ADFS support. I've also seen sometimes like people integrate their existing IDPs with one of these two options, even if they are not using Ping or ADFS. If it is working, then fine, but that's not what we support officially. Like right now, officially, we're just supporting these two, and we'll keep on adding more. Like the backend for both the SAML providers is the same, but the only reason that we are providing different, like we have different providers show up in the UI is because these are the ones that we have specifically tested, and we don't want to claim that we like any generic SAML provider that you add will just work. That's the only reason.
Okay, cool. All right, I'm gonna keep going. So Haridran asked two questions that are related, so I'm gonna read them both. The
Mm-hmm.
first is the best way to set up Rancher on bare metal via Docker? And then the next question is, I have a Kubernetes set up on bare metal, so should I run Docker as a should I run Rancher as a Docker container in a kube system namespace?
Okay, okay. So for the first question, Rancher is actually running out of a Docker container. So you do need to have Docker installed on your node, on your machine, because then, like we saw at the beginning, the command to install Rancher is just a Docker run command. So it will start a new container for you, and Rancher will be running within it. So yeah, you do need to have Docker running. And for the second question, if you already have a Kubernetes cluster running, and if you want Rancher to manage it, you don't need to run Rancher on that cluster. You can just go to the clusters page, and like I've shown, if you're adding a cluster, you can select this option of importing an existing cluster. Like that's what I did. I already had some RKE cluster running, but I didn't have to run Rancher on it. Instead, I ran the command that Rancher gave me. And yeah, that brought the cluster into Rancher so that I could manage it.
Awesome, cool, thank you. All right, I'm going to
Sure.
keep going. This is Marcus who asked, and you might have answered this earlier, but he asked, what persistent storage provider do you offer by default?
So by default, hang on. Oops, sorry. So like these are the list of volume plugins for persistent volume that you can choose from, and I don't really see anything being selected by default. Like you can just choose whichever one you want.
Cool. Okay, I'm going to keep going. The next one is from Eric, who asks, or he says, when creating distributed workloads, does it make more sense to create a single cluster across multiple geographic sites or multiple clusters which are load balanced?
I think a single cluster along different like geographic sites, it so I'm not sure, but this is what I think. It might cause some problems in terms of like if you have a load balancer sitting in front of it, which is sending requests to nodes of your cluster, which are like separated in different locations. If one of the locations is facing some problem, like the load balancer can take care of it. It can do health checks and stop sending requests to that one node, but I think it can still cause some problems. So I think the better way of doing it is by having all nodes in a cluster in the same geographic location and then having a load balancer. Yeah.
Cool. Okay, keep going. Um, the next one is from David, who asks, can we have visibility on the physical hardware resources usage? And does Rancher react to an overload by scaling up the number of nodes?
So we don't do the scaling up right now, but we are thinking of doing it. But I think in terms of visibility, this if you go to some cluster and select the nodes tab, you will get to see what all is going on for a particular node. Yeah, like over here the status and so on, system information.
Awesome.
Yeah.
Okay, cool. Actually, you might have just answered the next question, which is from Puneet, who asks, how is auto scaling handled for clusters itself? How do we link adding a new node with auto scaling rules, if any, are in Rancher?
Yeah, so like if you're using a DigitalOcean cluster, then there isn't exactly auto scaling as far as I know. But we are soon going to we are planning to do something for it.
Okay, great, cool. All right, here's the next question. Can I limit the network access between namespaces? Like pods and namespace A won't be able to access pods and namespace B and vice versa.
I think you can hang on. I'm not very much of a networking expert, or I don't even work that much with networking, but say if I go here, cluster options. I think this is what like you might be talking about, like the project network isolation. And if you're using the network provider canal, then you can select to have project network isolation enabled. I hope that answers your question.
Okay, cool. I think we did a networking masterclass that is on
Oh,
YouTube.
right.
That might help.
Yeah,
Uh,
definitely. Yeah.
the next one is also from Marcus. He says, on an on-prem node, can I limit VLANs to a certain namespace?
Yeah, I don't have that much knowledge about that. So I think again that networking masterclass that you mentioned might be able to answer that. And if not, there is always the Rancher user Slack channel.
Cool. Okay, let's keep going. The next one, there's quite a few. Oh, actually, there's only 5 or 6 more.
Okay.
The next one is from Martin, who asks, how can Rancher be backed up and restored in case of failure?
So because in the first high-level architecture diagram that I showed, we are using HCD for Rancher. So that's how you are backing up Rancher. Like the HCD store is being backed up and Rancher is backed up.
Awesome. Okay, sweet. The next one, it's actually another scaling question. It's from Kumar, who says, how long is downtime when scaling up an application?
When scaling up an application, I guess, so I think if you're using a deployment, and I'm not exactly sure that there's a specific value. Maybe Kubernetes has some default values for downtime of a pod when you're scaling up the application of that pod. But I'm not sure of whether there's a specific value for that.
Okay, no problem. Cool, thank you. Okay, the next one is from Powell, who asks, how do I add other ingress load balancers such as Traffic or Envoy instead of Nginx?
Right. So for that, let's go here and workloads, load balancer, and okay, so what I did is I selected one of the clusters. I went to a project in that cluster, and now I'm on the load balancing tab within workloads. So over here, you can click on add ingress, and this is how you can add ingress. And like by default, like we are using the Nginx or ingress controllers, but for like this is how you can add a ingress basically. you can select what service, you can specify what workload the routing should happen to. Yeah.
Awesome. Cool. Thank you. Okay, the next one is from David. What do you recommend as a best practice for a production environment? A single cluster of masters and nodes managed by a data center team, providing, so this is kind of a long question, might be outside the scope of this intro training, but we'll see. So he says, a single cluster of masters and nodes managed by a data center team, providing resources for the DevOps teams, giving Rancher access to DevOps to only a restricted number of features and a controlled volume of memory storage, etc.
Okay. So I think at the beginning you said that a single cluster of master nodes, right? I
Yeah,
yeah,
single cluster of masters nodes.
yeah, this might be out of the scope of this training, but I think you might want to have multiple clusters and like a separate set of clusters for the master nodes, like you said, and then a separate set of like clusters where like Rancher is managing and workloads are being deployed. Like I think that makes sense, but like yeah, I'm not sure I can give you the best answer for that.
Okay, cool. And
On
David,
our
I will,
docs, I guess we'll be able to find something with respect to. Okay, so I think in installation, like maybe the high availability installation docs might answer your question. Yeah, you can check it out.
cool. Yeah, and I was going to add that we have been wanting to get this kind of production environment training on the calendar for a while now. So this just adds more incentive to do that because a lot of people have been asking for it. So thanks for your question, David. And then the next one actually is from Andrew, who asked if you could explain again about backing up and restoring Rancher, or maybe give a reference to. If you just say it one more time. Didn't quite catch it.
Okay, let me refer the docs for that. Where do you keep? Hang on, sorry. Yeah, so this was the architecture diagram, and so in this, hang on. Maybe this is not what I was looking for. Yeah, so like it says here, the Rancher API server, it's built on top of an embedded K8s API server and etcd database. So, I mean, because you are like all the information is being saved in the etcd database, I guess that's how you'll be like that's how you are backing up your Rancher API server. Um, yeah, that's all that I can say.
Okay. I think we also actually have a blog article on that too. So I might try
Oh,
to find
great.
it before this ends, but we're coming near the end. So check, Andrew, check our blog because we did have an article on backing up and restoring from August, I believe. Okay, I think the last one is from Luis, who says, when spinning up latest versus stable, if you are using latest, does your Rancher environment auto update? I noticed that it does on Kubernetes management cluster.
Rancher environment auto update meaning to oh like if no, I'm not sure I get the question. Oh, the Rancher environment meaning the Rancher, like if you're using the latest tag and the new latest, like some new tag image is tagged as latest, then does your Rancher start running that tag? Um, I, I no, I don't. Yeah, I'm not sure of that.
Okay, cool. No worries. Well, Luis, if you didn't if you didn't quite get your question answered, you could ask on user Slack, or rephrase it. But yes, okay, cool. Yeah, he says, yeah, correct. Just curious. Cool.
Okay.
All right, awesome. So that is all the questions, Registry. Is there anything else you want to tell us before we close out?
No, yeah, I guess that's it.
Okay, sweet. So let me take back the reins just to give people the last couple slides so they have them for reference.
Sure, yeah. And I just wanted to add, like, sorry if I couldn't answer some of your questions because, like, I don't necessarily get to work with all the features, but please feel free to ask them in the Slack channel. Yeah.
Definitely. Cool. Well, so everybody knows, again, we have been referencing the Slack channel quite a bit on this training. Here is the link again, slack.rancher.io. It is free, open for everyone's use. And this slide, along with the others in the recording, will be sent to you hopefully within the next 24 hours. So look out for that in your inbox. And otherwise, that's all we have. Thanks everyone so much for your participation and your questions. If you have suggestions for these trainings, we were really trying to create some new trainings for the fall calendar. Please email me at matthew@rancher.com. I'd love your input. Otherwise, have a great rest of your week and weekend. Talk to y'all soon. And thanks again, Rajashri. Good job.
Thanks. Thanks for having me.
Yeah, absolutely. All right. Talk to y'all later.
Bye.